So in the last two classes, we have seen how to connect nodes and worked on with Gmail and connect our keys, right? So from this week, we are going to go into like some advanced topics that would be the flow. Okay. I'm sharing a whiteboard. Please confirm if you can see this. Okay. So as I told, RAG is basically nothing but it starts with retrieval augmented generation. So it's basically not all your LLMs will know your personal information. Let's say you have your data set, okay? So HR policies or some other data sets which are related to your company or your use cases, right? So that cannot be known by LLM model. LLM is just act like a knowledge base, right? So in that case, this RAG will get used. For example, we'll start with a simple example. I hope my screen is visible. Okay. Let's say you're going to a doctor. Okay. Imagine that doctor is a new doctor who has never met you. Okay. So you're going to a doctor. So we usually have two kinds of cases. We may have a family doctor, or you're not just going to a new doctor, which you have never visited him. There are two kinds of scenarios it can come. If you go to a family doctor, so he usually knows your history, right? So he knows your history means he knows the full history about yourself, like what's your patient record and how long you have been visiting here, what are the previous medications you are taking, everything will be known here. Okay, but when you go to a new doctor, he might not have any previous records to it. Okay, they don't know your history, allergies, or past treatment. Answers are with generic. So on that time, you're taking your medical records also with you. Okay, in this case, you're taking your medical records and going there. So assume this is a doctor plus RAG. He can give you personalized informations based on your history. So similarly, RAGis works on the same way where it can analyze our documents and produce relevant question and answers to the questions which you're asking. So it's basically a document analysis. So if you ask some question, instead of manually checking and answering, the RAG will automatically check it, generate the answer based on the document which we gave. So anyone have doubts on this understanding RAG? So I just explained in a high level what is a RAG. Anyone have doubts on understanding what is a RAG? Can we move to the technical part? So here, basically to summarize, the AI is the doctor and your documents are the medical files. So RAG will support to answer those questions. Anyone have doubts? Okay, let me reiterate once again on the same thing. You have this is someone who has already experience on LLMs. AI can understand this RAG terminology clearly. If you are really new, never know this terminology, it will be hard for you to grasp at the first time. Okay, so I will explain you another time. Let's say your company has a HR policy document. Okay, this HR policy document, you need to connect it to your LLM. Okay, so let's say you are building uh, a bot with respect to explaining HR policy questions, right? So this is the case. Let's say you're asking what is the office working hours to a chat GPT. What it will tell from a normal, what it has been trained on the previous data, it will tell. But as per your company, the timings are 9:30 a.m. to 6:30 p.m. This informations we need to fed into the LLM, right? So the RAG will allows you to connect your custom documents to the LLM to the generation. The training data of LLM will be cut off during the training time itself. So let's say if you take GPT or any models, it will cut off with at the year of 24, 25 or something. So whatever happens post that, right? Let's say if you ask about what happens in the war today, if you ask this to the LLM, it cannot answer. It might need some external resources to answer it. Let's say web search. Web search is also a kind of RAG which helps on LLM to search relevant information with the current trend and answer the question belong to it. Anyone have doubts still on this understanding? Assume you are feeding some extra information to the LLM model, which is supports on the explanation with respect to your use cases. Is it clear now? We'll just deep dive more onto this. In a higher level, is it clear? Can we move forward? So another example is we have school exams. There will be two cases they will conduct exams. One is closed book exams and another one is open book. So in case of closed book, what will happen? It is a normal AI. Assume like a normal AI where it will answer from whatever it have learned, right? So this is what normal AI does. So it only knows what it is memorized during the training process. Assume it's in a learning process. If the answer isn't in the memory, it guess or make up things up. It tries to guess. But in open book, what we will do, it will go to a certain search certain pages and get the answer and write the answer. We will write the answer from it. So similarly, assume open book is a RAG. In this case, the AI will allow to view all the pages in a document which you uploaded and fetch the relevant information belongs to the particular question you have asked and it tries to answer. It finds the right pages and it reads it and answer it. Anyone have doubts still on understanding what is RAG? This is one of the simplest example to understand high level what is a RAG. Anyone have doubts until here? Can we move forward? Anyone have doubts? Can we move forward? You're giving your personal information or any generic cases which is outside of LLM memory is RAG. That's it. Okay, all right. So the RAG has two different components in it. Please understand it clearly. Then I will just straightforwardly move from theory to the implementation. On that time, you should not get suffered. Okay. So just take notes if necessary. Anyone knows what are the two steps available in RAG? Anyone knows what is the two steps which is involved in the RAG? Please type yes or no, or else I will get bored during the class. Just interact with me. Just say you know or you don't know. So it will be better for me to explain. A agent, ADD database. Okay. Okay. So most of your answers are wrong. So I will start it. So RAG has two-step process. One is embedding process. These are high-level AI terms. So please follow along with me, or else it will be hard for you to understand. Okay, these are like really high-level terms. Whatever I'm going to explain, and please follow with me. I will try to solve it with simple examples. So if you follow only, it will be easy for you. This terminologies you have to search with respect to RAG. With N8N, you might not get few of these terminologies also. Okay, so please follow along with me. It will be easy for you to understand. Next one is retrieval. So there are two uh, concepts in the RAG. One is embedding process and the retrieval process. Okay, embedding process is basically, anyone knows what is embedding? So I just told you now there are two processes. One is embedding process and another one is retrieval process. Anyone knows what is embedding process? Okay. So first we'll start with embedding. Embedding is giving information. Not exactly. Okay. All right. So anyone can tell uh, what things computers are better at. They can understand numbers or they can understand text informations. Computers are better at what? They can basically understand numbers, right? So what we are going to do, so to put in simple terms, whatever the text you have, which will be converted into list of numbers, list of numbers. This is the first step. So you have a text, then that it will be converted into a number. You can ask me a question, how can I do a text to number? It's easy to convert from English to Hindi. So we just do a translation, right? From one form to another form. Here, the form of representation is text. You are converting from the source is also text and the destination also text. But in case of embedding, what you will do, you will convert that into a number. This number is nothing, is a vectors. Anyone knows what is vectors? Maybe we have studied in 12th standard, I guess. What is vectors? Oh, vectors. What is vectors? So vectors are which has a dimension with it, which you can find a direction and along with distance can be calculated. So that is a different, that is the thing. Okay. I will give you another example how in vector representation the numbers will be looks in the later stage. So only thing we need to understand is we have text and numbers. Okay. First, you have to understand in during the process of embedding, you have a list of text in it that needs to be converted into vectors and that has a meaning of information. Okay. So we just represent that in some information and store it. So this is what happens in the text to number conversation process. For example, you have a text You have a text here, like I love cats. Like this, you have a text, right? This text, what will look like, as I told, numbers means it will look like in a dimension. How long this will go? How much dimension it will have? It depends on the embedding model. It can go 512 or 32 or 64. Mostly we will use 512 as a embedding size means. So there will be a vector contains of 512 dimension in it. Inside this, there will be 512. Okay. So why we are storing it numbers means computers cannot actually compare the meanings directly, but they can compare the numbers fastly, compare it to the text. So instead of asking these two words are similar, we will ask, is the two list of numbers are similar or not? So asking I love cat and I love dogs. Instead of that, you convert that I love cats into a vector and I love dogs into a vector and ask the computer to calculate the similarity. It will be faster. The process of calculating similarity between two vectors is called as, what is that? What is the measure? Anyone knows? This also we have been studied in 12th maths, I guess, 12th grade maths. This is called as cosine similarity. Please don't tell they told it is a no-code platform, but you are teaching mathematics in this class. This is very important for understanding RAC. That's why I'm telling. The process of calculating similarity measures between multiple vectors is called as cosine similarity. The range of cosine similarity usually uh, ranges from 0 to 1. The similarity score you might learn. So I'm just, so if it is 1 is, which is more closer. If it is like 0 means it's not closer. Any doubts until here? How the process works? Assume you don't need to think mathematically, just think there will be a text that will be converted into a numbers. Then we will have multiple number of vectors. So we will use cosine similarity to basically get the closest relevant dot text vector from it. Anyone have doubts until here? Anyone have doubts until here? Okay. So what are the steps in the vector process I told? What is the first step we should do when we have a text? When we have a text, what is the first step we have to do? We have to, um, I didn't come to that chunks point. I will come to chunks. Assume now you have four words that you need to convert it into an embedding. That is the process, right? So now let's go in some deep. So is my screen is visible? Okay. So first step is you have a raw documents. Raw doc means your PDF, your Word document, your XLX files, or your CSV files, your PPTX files. These files are raw document. Okay. This documents needs to be extracted and converted into a text format. The process of converting raw document into a structured format is called as data parsing. The data parsing is nothing but when you have a data that needs to be converted into a structured format, so which can be easily chunked and used it later. Okay, that is called what? Data parsing. Once your data is parsed, that needs to be chunked. See, you have this much data. Okay. This whole data you cannot directly store into a table. Okay. So assume you have a raw data like this, then you will copy this and make it as a structured document. Structured means everything looks commonly. After that, you cannot pass this every information directly to the embedding model. You have to pass small by small only. Assume there are two things which defines how to chunk it. So there is chunk size. First is chunk size, then another one is overlapping. It's two terminologies I will explain. What is it? Chunk size is how many size. That is basically a token. Token is how much, assume like how many words that has been fit into a certain limit. I told you 512 vector size, right? Or 1536 vector size. Like this, there will be multiple vector sizes. Okay, so how much size it can fit in. For example, I make this is a first chunk. This is my first chunk. Next chunk is this one. This is an example. But really, when you're making chunk, it might change. So I just want to show you what is a chunk basically. So I'm just making whatever is the point that is that as a new chunk. Anyone have doubts on understanding what is a chunk? So you basically convert split things into multiple parts and put into a vector. Okay, then what you do, see, when you're splitting into chunks, right? What happens is like there needs to be some overlap should be there. The purpose of overlap is to have a connectivity between the previous chunk and the current chunk. Okay, this is more important. For example, what is overlap means we'll take some part of this and put into the previous chunk itself. So that there won't be any issue on overlapping. So you got it, what is overlap now? So to make the current chunk know what happens on